So, what we had as a question for was this one. Again, we've got to split this up, similar to the one we did before. 3r squared minus 3 sigma r plus sigma 2. And again, we had the same problem for some people, that this would be 3 times 1/6 n plus 1 to n plus 1. This one we would be subtracting 3 times a half n plus 1. And this one would be adding 2 times n. Because the sum of 1 as r goes from 1 to n is just n. So that's what we start out with as our big expression to do something with. The common factor that we're going to bring out here is going to be a half, isn't it? Because we've got that is actually a half, and that's over 2, and that we can put over 2. So we're going to bring out a half. We've got n as a factor as well, and that leaves us with, well, that's all very nice, that leaves us with n plus 1 to n plus 1. Here we're going to have a minus 3 lots of n plus 1, and here we're going to have a plus 4 to give us the 2n, because 4 times a half n gives 2n. So inside the square bracket there, we've got 2n squared plus 3n plus 1. Now this is a common place to make a mistake. Really careful with all these brackets, don't just kind of blast through it carelessly. Minus 3n, take away 3, plus the 4 there, because it's minus in front of that bracket. So we've got half n, 2n squared, 3n, take away 3n, so the n's cancel out altogether, and we're left with, what have we got? 1 minus 3 plus 4, which I think is plus 2, isn't it? And the question said, expressing your answer in a fully factorised form. So at this point we're not quite there, it's not fully factorised. If we bring that 2 out as a factor, 2 times the half will leave us with n times n squared plus 1. And that was the delightfully simple final answer. There we are. Okay?